Today I'll show you how to take a 3D capture from Google Maps or Google Earth and bring it into your preferred DCC software so you can use it in your scenes. It might sound like a bit of a complicated process. That's because it is a complicated process, but once you get it nailed down and with everything ready to use, it will become less of a hassle. So I'm recording this in the first place because I couldn't really find a good tutorial that both explained the workflow clearly and at the same time went into enough detail about how and why everything worked the way it does. Most of what's out there is either outdated and no longer works or just shows a process without much context. So I wanted to make a video that hopefully does both things, being something straightforward but at the same time complete enough so that you can actually understand what's happening behind the scenes. This workflow is great if you want to add a quick city context, a rough background geometry, or just use it for things like shadow projection, camera matching, for reflections and refractions of your background, stuff like that. The only catch here is that it only works with a few very specific versions of some software that we'll need to get. But in this video, I'll hopefully go over everything step by step, and you'll find all the download links and commands in the description below. Okay, let's start with explaining what's actually happening here. So when you move around in Google Earth or Google Maps, as you can see, you're not just looking at the flat satellite photos, but really you're actually seeing the full 3D geometry around us. Over the last couple of years, Google has built this 3D geometry using a mix of aerial photogrammetry, satellite data, machine learning. So basically, they have planes and drones flying over cities alongside the satellite imagery, and they capture overlapping high-resolution photos from all sorts of angles. And with this, with computer vision, they reconstruct the depth information and create these 3D meshes. To grab these 3D information, we're going to be using a tool called RenderDoc. RenderDoc is a graphics debugger. It's a free program that lets you capture what your computer's GPU is rendering at any given moment. So essentially what's happening here is when Google Maps is showing a 3D model, RenderDoc intercepts these draw calls and saves everything as a capture file that's called an RDC, a RenderDoc capture file. Then inside Blender, we're going to use an add-on called Maps Models Importer to open this file, rebuild the geometry into a workable geometry format with textures and export it as an FBX, for example. From then on, you can bring into any DCC application of your preferred choice. Before we move on, however, I need to make a little legal and security disclaimer. I need to mention that this process is meant for educational use exclusively. Always check with Google's terms of service before using these captures in any commercial project. You shouldn't really redistribute or sell any of the data that you're going to be extracting. Also, since this method uses older versions of software, keep in mind that these have security risks. They don't include security patches, so please only use these tools for this purpose. Don't browse the web with them, don't log into any accounts, don't install extensions, any of that matter. Make sure to keep this setup completely separate from the rest. So one tip I'm going to give you right here, make a dedicated folder on your desktop and call it, something like Google Earth Capture, something like this. In this case, for the purpose of this video, I'm going to be calling it Google Earth to 3D. This is where you're going to be keeping every legacy version of softwares that we're going to be needing for this workflow. So let's jump right into it and get started. We're going to need 4 tools. A specific version of Google Chrome, in this case a portable version of Google Chrome, that predates a patch rolled out by Google to disable this capturing of draw calls. RenderDoc 1.31, any newer versions of RenderDoc will probably not work, so I recommend using only the links that I'm going to be sending in the description below. Blender 4.1, and this add-on for Blender 4.1, Maps Models Importer. So starting off with the installation of this Google Chrome portable version, you're going to proceed with the installation as normal. In this case, since I already have it installed in my machine, I won't be installing it again. But one tip for you, since it is a portable installation, please set the destination folder to this folder that we're going to be creating in our desktop. We're also going to be installing RenderDoc 1.31. Proceed with installation as normal. In this case, I also already have it, so I'm not going to be doing it. And same thing with Blender 4.1. Now I'm getting an error because I already have it installed as well. If this is your case and you already have a specific instance of Blender 4.1 and you wish to keep it completely separate, even the Blender program, you can install a portable version of Blender for that matter. But in this case, it isn't specifically needed, it isn't a requirement, so we're not going to be doing it. And finally, this is the add-on. We're going to be installing it into Blender when the time comes. So if you've done everything correctly and have everything installed, you should be left with these 3 softwares: Google Chrome, RenderDoc, and Blender 4.1. I'm going to leave the add-on the side for the moment. So if everything worked out correctly, your folder should look like this. Just full empty with this folder called Google Chrome Portable inside of it. You're going to head to this Google Chrome folder and you're going to create a shortcut of the Google Chrome Portable exe file onto the root of the folder. And while you're at it, also create a shortcut of your RenderDoc version and Blender version. Okay, you're going to head to the properties of this Google Chrome Portable file. And in the target field, I want you to go to the description of this video and copy paste the command that I specified there. Okay, when pasted, you'll note that you have a place to write your directory, as you can see. So what we're going to be doing is heading to our Google Chrome folder and we're going to just copy as path. Now, when you copy as path, you get these quotation marks that can be very annoying here. You'll just have to remove them. You can do it as I am doing here and just use this to copy the text. And now you can select this directory text and just copy paste on top of it and apply. Perfect. So if you've done everything correctly up until this point, your folder should look a bit like this. The Google Chrome Portable installation file, Blender 4.1, your custom version of Google Chrome Portable, and RenderDoc. We're going to be starting by opening Google Chrome Portable, and you'll see this white window and a little pop-up with a PID code. You can leave this on the side for now. After this, you're going to be opening RenderDoc 1.31. Please do not update your RenderDoc version for this to work. You can choose to rename these shortcuts with don't update or something like this in order to really nail down in your head not to update these softwares. And when in RenderDoc, we're going to be heading to Tools, Settings, General, and we'll be looking for Enable Process Injection, Restart Required. I already ticked this, but you probably will have this unchecked, so please check the box and feel free to restart RenderDoc. All right. Now that it's done, you'll head to File, Inject into Process, and in Filter Process List, you're going to be typing the PID code. In this case, it's this one, and double-clicking on the Chrome entry that'll appear. Perfect. Now RenderDoc is hooked onto the Chrome version, so it'll be capturing the draw calls that it receives from the software. We can finally check the pop-up, and it'll look a bit like this. So let's split the screen to make it a bit easier. So now we have Chrome on one side, RenderDoc on the other. Note that my Chrome version has a red theme. I've done this specifically to make it so that I don't confuse this with any other Chrome version that I might have installed on my computer or any browser for that matter. You should do it too, just to make sure that you are always aware that this is an unsafe version of a browser and to remember you not to go browse as usual. So to set this theme, you go to Settings, You and Google, customize your Chrome profile and just pick a theme color. You can pick whatever. In this case, I'm just choosing red. And after this, we're going to be heading to Google Maps. Also, to make sure that everything's working correctly, you should be seeing this debug overlay on the top of your Chrome window. Okay, heading to Google Maps now, I suggest you pick a location you're interested in. A word of advice, some locations don't have any 3D geometry to them. This is due to local, geographical, and political reasons. So pick one that has 3D graphics attached to it. One way to check is going to Maps, picking the satellite, terrain, view mode, checking more options, and enabling globe view, and here, satellite view as well. And you can disable labels or tags. Now you just shift drag in order to orbit, pan around your preferred location. So this sounds about right. As you can see, Google Maps/Google Earth utilizes an LOD system in order to process its geometry and textures. For those who don't know, LOD stands for level of detail, so it essentially dynamically adjusts the resolution of the geometry and the resolution of the textures being displayed here based on the distance that you're seeing things. Right, so now having your setup concluded, you just need to head to RenderDoc and press the Capture Frames Immediately button. And before pressing, I want you to try to quickly rush to your Google Maps window and just wiggle it around a little bit so it can help the software detect that it's receiving draw calls and converting them or capturing them in this case. So capture frames immediately, and we're just going to try to wiggle it a bit. So now you'll see it collected a capture. We're going to double click on the capture. And if you see that it has more than 3 color passes, or better said, 3 or more color passes, then it has most likely been able to correctly capture the draw calls from your website. So this should be more than enough for us to utilize. Now be aware that it should capture what you're seeing on the window. If you want to capture a larger area, you can zoom out. However, as I mentioned, please note that the geometry will most likely be more coarse since you're farther away from your center of attention, or in this case, your hero subject. So what I suggest doing if you want the best of both worlds per se is being up close to your hero object and capturing it, and then doing the same thing to the nearby locations that are relevant to you and that you need in high res, and then bringing them over to your DCC software, in this case Blender, and stitching them up. I'll explain how to do this in just a minute. So we're going to be selecting our capture and heading to File, Save Capture As, and for the purposes of the video, I'm going to create a folder called Exports in my desktop, like a madman. File name, we're going to be calling it just the Colosseum, and now we can minimize these 2 windows since we're not going to be needing them for the moment. Okay, in Blender 4.1, just briefly for those who never used Blender, to pan on your screen, you're going to be Shift middle clicking, and to orbit, you just need to middle click and drag. All right, to zoom, you Control and drag, and that's all there is to it navigation-wise in the viewport. So to install our add-on, we're going to head to Edit, Preferences, Install, go to the directory where you have the script, and you don't have to unzip it, by the way. Select the zip file corresponding to the add-on and press Install Add-on. Now just search for Maps Models Importer and make sure that this checkbox is enabled. In Blender, you can head to File, Import, and Google Maps Capture. We're going to be heading to our Exports folder and selecting our RenderDoc capture file. So let's see what RenderDoc has captured from the draw calls in our Google Maps website. Okay, so here we are. So the results might vary tremendously. In this case, as you can see, it has exported the whole globe. No, but you'll find it somewhere. In this case, it seems to be here, but very small. So scale is an issue. You'll have always to make sure everything is in the correct scale. In this case, I'm just gonna do it very, very roughly. So just press A to select everything and scale to scale up everything. And we're gonna be just quickly heading over to N, View, and reducing the clip start and increasing the clip end, since we're working with very, very big measurements here. And let's find our geometry. It seems to be somewhere here, so you can just press on the period key to zoom into something. And here we are. The capture actually looks quite good. We just have to isolate the rest of the crap and scale everything to the correct measurements. So one thing I'll point out, as I said earlier, the geometry gets coarser the farther you get from your point of interest. As you can see, the buildings here are already quite coarser than the ones you'll see nearer of your point of interest. So that's number one. Thing number two is that you might notice that this is captured in chunks. So what I was mentioning earlier about capturing different areas of your region and then stitching them together is to exactly do the same process, import multiple render captures and then stitch the ones that are higher res together in order to kind of counter this LOD effect. So in my case, I'm just going to select the nearest region to the Colosseum, and I'm going to head to File, Export, and I'm going to make sure I limit it to selected objects. So this is the equivalent to a save selected in 3ds Max, for example. I'm going to just quickly set the up axis to Z positive, and the forward one is a bit irrelevant, but X minus forward seems to be correct. We're going to export the FBX, I'm going to do it to the exports folder as well. Now we're going to be opening 3ds Max. And just a word of advice, before we import it into 3ds Max or any other DCC application for that matter, make sure that you have the textures that were also exported from RenderDoc on the same folder of your 3D export, so that nothing is lost and that every texture is properly linked to the model. Now, of course, keep in mind that the geometry will not be perfect. It's a generated mesh, so it will look a little blobby, softer on the edges, a bit coarse in a lot of areas, but it's already quite good, as I mentioned, for camera matching purposes, for having reflections or shadows in your photo insertions, or just playing around for some less realistic projects. It can look quite nice. So now in Max, just for the purposes of showcasing how this works, you'll just pop in your FBX file, import it into your scene. If you haven't done it in Blender, please adjust the scale for it to be correct here in 3ds Max or your DCC software of choice. In this case, we're also suffering from the same issue we suffered in Blender, the camera clipping problem. So we're going to be heading to here, our perspective tab, and viewport clipping, and in this case, adjusting the clipping so that it stops intersecting. And there you have it. This is how you convert Google Maps or Google Earth scan into a usable 3D model you can bring into any DCC of your choice. I know it takes a little bit of patience, especially on the first time the setup, but if you get everything set up properly and you have everything condensed in one neat folder, you should be making your workflow as easy and painless as possible, given the circumstances. Right, so all the links, versions, commands are going to be listed down below in the description, alongside a short checklist for you to check out and to make sure that you got the whole process nailed down. I hope the walkthrough helped make the process a little bit clearer for you. I know it's a little bit convoluted, but hopefully that mist has cleared up and it's easier for you to understand now. I'll be sharing more content like this, so feel free to stick around if that's your thing.